Hello and welcome to Tribe Topper. In this video, you are going to learn the second part of topic 2.2 from mechanics, that is free body diagrams. So first of all, what is a free body diagram? A free body diagram is something which shows or indicates the relative magnitude and direction of all forces that are acting on an object. Like if whatever is given to us, we label all the forces along with their magnitudes and the directions that are acting on a body. As you can see here, this is the first free body diagram. So if you suppose that there is a ball which is hanging, and this is, you actually have tied a string to it and attached to a knob here, a fixed hook. Now, if you pull it to one side, and at this point, what are the forces that are acting on this ball? You can see there are two forces. One, the weight as marked downwards, W, and the other is the tension in the string which is attached to the ball, right? So because there will be a stretch in the spring, in that string, which will be acting in this direction as shown. When you have to solve it, what you'll do is you will have to mark some more parts of it. So we'll say if the string is making an angle theta with the vertical direction, then we have to split up this tension into two parts. And what will be those two parts? The tension will have one horizontal component and it will have one vertical component. So that is going to be labeled as T cos theta in T sine theta in this direction and T cos theta in this direction, because always your theta has to make sense how it decides which side is going to be sine theta and which side is going to be cos theta. Like in this case, if I mark this triangle as A, B and C, theta is the angle between the adjacent and the hypotenuse. So AB is acting as the height. So if height or opposite is acting here, then this opposite over hypotenuse will be T sine theta, will be sine theta, but when you multiply T, so you get it as T sine theta. And the other side, this way, it is going to be T cos theta. And then based on any question, we figure out if it is in equilibrium, we would say T cos theta is equal to W. And if it is in equilibrium, right? So T cos theta would be equal to W, which is balancing out the weight. And because it is going to go back, obviously if you have stretched it, this ball will go back like a pendulum. So T sine theta is going to provide it a restoring force. You're going to learn about these forces soon. So we can't talk about it much now. So we can move on to our next diagram. If you see here, you have a block which is lying on an inclined plane. So I told this to you in the last session also, that how will you label the forces when you place it on an inclined plane? So if you are pushing the block up, what are the forces that you will label? Number one, the weight always acting vertically downwards, which will be your mg, this side. The normal reaction has to be normal to the surface of contact, so it will be this way, normal. And the applied force is F in the upward direction. Sometimes they also mention that there is a force of friction acting. Then you will label the force of friction in this direction acting downwards, because it always has to oppose the motion. So now we have marked all the forces that are acting. So this is a free body diagram for our given situation. Now let's have a look at a question which is given here, that a ball of weight 10 Newton is suspended on a string and pulled to one side by another horizontal string as shown in the figure. So here is the figure. This is showing that a string is attached to a ball of weight 10 Newton and the weight is acting vertically downwards and it is pulled to one side by another horizontal string. So one is this string with which it is attached, and that has been pulled by applying a force to the left horizontally. That makes it now, so the string will make an angle of 30 degrees. Write an equation for the horizontal components of the forces acting. The horizontal forces that are acting here are, one is this horizontal force, you can see F, and we also have to split up this tension into two components, one in this direction and one in this direction. So what are the horizontal forces that are acting here? Number one is you will have t cos theta and t sin theta. So this side again, you're going to have t sin theta, and this side you're going to have t cos theta. So we have t sin theta acting to the right and minus F acting to the left. This is the net horizontal component of force acting on the ball. And then we have to write an equation for the vertical components of the forces that are acting on the ball. You can see the vertical forces acting are T cos theta upwards and 10 Newton downwards. So 10 Newton minus T cos theta, right? These are the two forces that are acting. So since it is balanced, so the resultant force is 0 here also and it is 0 here also. So the first one tells us that force F is going to be equal to T sine theta, and the second equation tells us that 10 Newton is equal to T cos theta. So let's find out T. That gives me T cos theta is equal, or I would say 10 Newton is equal to T cos 30. So T cos 30 is 10. So what is T? It is 10 over cos 30. Cos 30 value is root 3 by 2. So 3 and 2 goes on the top. So it's 20 over root 3. That's the value of the tension in the string, which probably they have asked us to find out later. Yeah, so the C part is saying use the second equation to calculate the tension in the upper string. So that is 20 by root 3. And using this value of T, then you can find out the net horizontal force. So if you put this value here in this equation, you will get the value of the force. So F is equal to T sine 30, which means it is T. The value of T we found out is 20 by root 3 into sine 30 is half. So the force acting is 10 over root 3. So the horizontal force acting is 10 over root 3 Newton and the tension acting is 20 over root 3 Newton. So this is how a free body diagram helps us to determine the resultant forces that are acting on a body. That's all for this session. In the next video, you are going to learn about the elevator problems, which will also be based in somewhat related to the free body diagrams and equilibrium of forces. That's all. Thank you.